The first question on the quiz is going to be either linear approximation or some approximation differentials, and the second question will be something to do with gradients. Okay, so let's begin. So you're given the following equation. F of F of x, y, z is equal to the square root of x squared plus y squared plus z squared, and your point is going to be 3, 6, and -2. And they ask you to find the direction of max increase, or let's say mass rate of change, and what this rate of change is, and what this rate of change is. Any questions about what the question is? Yeah.
What's this process called?
This is called the finding the direction of greatest increase or the greatest ascent or something like that. So you're trying to find, yeah. Any other questions? Okay, so the direction, like we've said, the direction of greatest increase is the direction of the gradient. So all we need to do is find the gradient with respect to f, which is the partial of f with respect to x, partial of f with respect to y, partial of f with respect to z. And what we're really looking for is the gradient of f at the point P. So, and again, they give us the point P. So let's just first try to find what is the gradient of f at x, y, and z. So going to our equation, the partial with respect to x is going to be 1/2 square root of x squared plus y squared plus z squared times the derivative of the thing inside with respect to x, which is 2x. So this 2 cancels with the 2 that comes out, and you get x up here. Any questions about this step so far? And then because this is symmetrical with respect to y and z, you can just say it looks the same thing with respect to y. So that will be y over the square root of x squared plus y squared plus z squared. And the same thing will happen in the z direction. So it's going to be z over the square root of x squared plus y squared plus z squared. And that's going to be your gradient vector. So now the gradient vector of f at the point 3, 6, and -2 is going to be, and I'm not going to calculate this whole thing out, but 3/7, 6/7, and -2/7. So this is going to be the direction of greatest increase, right over here, which means that if you were in your three-dimensional space, x, y, z, and recall the map f over here maps you from this three-dimensional space to some one-dimensional space, which is, let's say, w, which is equal to f of x, y, z. And so, and if you're at the point 3, 6, -2, so maybe some point down here, 3, 6, -2, and you go in the direction of 3/7, 6/7, and -2/7. So let's say that that is something like this direction over here. That's your gradient vector. Then in that direction, taking a very small change in this direction is the greatest change that you have in the direction of your f. And so then what is the rate of this change? So what you need to do is you need to take the magnitude of your gradient vector. So the magnitude of your gradient vector at the point 3, 6, -2, that's going to be the rate of change in the direction of greatest increase. And that is going to be 1. So you're in fact going in the positive direction, right? Because this is positive, and that's your maximum rate of change. So if you go in any other direction, this direction, any other direction, your rate of change will be smaller than 1. Any questions about this problem? Okay, so if there aren't any questions, we can move on to the chain rule. The next section. So the chain rule, if we remember from Calc 1, if you have, let's say, some f of x is equal to f composed with g of x, then the derivative of f with respect to x is going to be the derivative of f, and then g remains the same times the derivative of g with respect to x, right? That's the chain rule for Calc 1. So we want to build on that in 2 ways. And the first one will be simpler, and the second one may be a little bit more complicated. So the first one is, let's imagine that you have some z, which is equal to f of xy, but now your x is equal to some function with respect to t, and y is also equal to some other function with respect to t. So what's really going on here is z is really only a function with respect to one variable, and that's t. As you change t, it changes both your x and your y based on these functions. What's an example of this? Well, we can say, let's say z is equal to x squared plus y squared. Give me a second. Okay, so yeah, we can say something like this, but then we can also say, let's imagine that x is equal to cosine of t and y is equal to sine of t, right? So now we have some function which we wrote with respect to x and y, but then we said how x and y relate to t. So you can also rewrite z. You can say my z is equal to cosine of t squared plus sine of t squared. That's another way of writing what this function is. But if I wanted to, without rewriting this function, and we'll see why we sometimes just don't want to do that, it can just complicate things. If I want to find the partial of z, so the derivative of z with respect to t, and the reason I'm saying the actual derivative and not the partial is because that z is only dependent on t. It's not dependent on two variables. So you can take the actual derivative, and when you want to do these type of partials, my recommendation is make the following tree. Some people do a directed graph. I don't think it works nearly as well. So you put your z on top, and then you say what variables does your z depend on? And it depends right now, your z depends on x and y directly. So you put x here and y here. And then what variables does x depend on? Well, it depends on t. So you put a t down here and you put a t down here. Now, if I want to know what is the rate of z as I change my t, right? The question is I'm varying my t and I want to know how does my z change? Well, that's going to be, you go from your z and you say, well, there's a certain portion of change that you get from your x direction, and that's this over here. And that's the partial of z with respect to x. And you're taking the partial because z has two variables associated with it, this variable and that variable. So you're taking the partial. And then you say, and how is x changing with respect to t? So that's going down here. And that's the derivative of x with respect to t, because x only has one variable. And that's the first part. And then you add to that, and then you go down the next part of your graph. So you go here, and you say, well, how is my z depending on y? And that's the partial of z with respect to y. Again, you do the partial because you have two variables here, the y variable and the x variable. And then you go down in this direction, and that is the derivative of y with respect to t. And this is going to be your derivative of z with respect to t. Does that make sense? Any questions about this? Yeah? Yeah. Yeah, so it's a proportion type game. So it's what proportion does z change with respect to x, and what proportion does x change with respect to t. You multiply them to get the total proportion that z changes with respect to t from the x direction, from whatever is happening in the x direction. And then you do the same thing in the y direction. Any other questions? So let's do this with the example from above. So if you want now to figure out what is the derivative of z with respect to t, so that's going to be the partial of z with respect to x, which is 2x, times the partial of x with respect to t, which is negative sine of t, plus the partial of z with respect to, so again, z with respect to y, which is 2y, times the partial of y with respect to t, which is going to be cosine of t. Now notice that there are like x's and y's here, but you can say that this is also equal to 2, and we know that our x is equal to cosine of t. So 2 cosine of t times negative sine of t plus 2, and our y is equal to sine of t, so 2 sine of t times cosine of t. Any questions about this? Yeah, it will be equal to 0. And the reason it's equal to 0 is because this equation is 1. So now my z is 1. So the derivative of z is 0. Any other questions? So of course, in these simple cases, we can, rather than use this formula, we can say, well, if my z is equal to x squared plus y squared, and my x is equal to cosine of t, and my y is equal to sine of t, what happens if I just plug them in? So my z now is equal to cosine of t squared plus sine of t squared. And if I did not know any trigonometric identities and I just wanted to take the derivative, it's now some function only with respect to t. So what's the derivative of z with respect to t? Well, that's going to be 2 times cosine of t minus sine of t plus 2 sine of t times cosine of t, right? Which is exactly what we got above. So both of these methods should, of course, work because they're doing the same thing. But this new strategy will help us in more complicated examples. So let me do one other example like this, and then we'll go to the cases where the chain rule really helps. So let's say we say z is equal to z is equal to xe to the xy, and x is equal to t squared, and y is equal to t inverse. And rather than plugging in what all of this is, we can just use the formula. So again, we build our tree x, build our tree, which is our z, depends on x and y, which both depend on t. And then we say the derivative of z with respect to t is the partial of this with respect to x. Well, what is that? That's x times the derivative of this, where the y just comes down. So it's x times y, e to the xy, and then plus the derivative of this with respect to this, which is just e xy. So this is the derivative with respect to x. So this is the partial of z with respect to x. And then you multiply that by the derivative of x with respect to t. So that's going to be 2t. And then you add to this whole thing plus the derivative of this with respect to y, so that is x squared exy, times the derivative of this with respect to t, so that is going to be times -1 t to the -2. And now we can just plug into our x and y some our variables, so we can get that this is equal to t squared times t -1 ... So just plug in your x's and your y's into the x and your y, and you will get some formula only with respect to t, and that will answer the question. Any questions about this problem? Okay, so let's go on to the next type of thing that we would want to do. So that is now we would want to be able to find if my z my z is equal to f of xy, and my x is equal to some g of st, and my y is equal to some h of st. So now my x and my y don't only depend on t, they depend on two variables. And let's say I now ask you, what is the partial of z with respect to x? With respect to s. With respect to s, right? S changes your x, and your x changes your, f, which changes your z. So of course there's some connection, some relationship between them. And the question is, what is that relationship? And similarly with y. So when you do a problem like this, you end up drawing the same exact tree from before. So you put a z on top, and then you say, okay, what are the variables that my z depends on? So my z depends on x and y. My z depends on x and then y, right? That's this z is a function of x and y. So now what does my x depend on? My x depends on my s and my t, right? Functions of s and t. And my y also depends on s and t, right? Again, y is a function of s and t. And then in order to get the formula for your current partial, so this partial is going to be, and you do the same thing as before. How does my z change with respect to x? So what is that? That's the partial of z with respect to x. And then how does my x, so I'm trying to find the change with respect to x. So what is the partial now? Because there are two variables here. What is the partial of x with respect to s? So that is the partial of x with respect to s. So far, so good? Plus, how does my z change with respect to y? So the partial of z with respect to y times how does my y change with respect to s, right? A certain change in my s also changes my y. So how my y changes with respect to x. And that's how this tree helps you figure out what formula to write. It's just the path on the tree going down to s in one direction, and you put them together, multiply them. And then the path of the tree going down to s in the second direction, and you put them together and you multiply them. Any questions?
You have to do it for t as well.
No, because we only want to change with respect to s. So you look at that s and you know which path you want to take. Any other questions? Okay, so let's do an example. So let's say you're told that your z, is equal to e2r sine of 3 theta. And then you're told that your r is equal to st minus t squared, and your theta is equal to the square root of s squared plus t squared. And you're asked to find the partial of z with respect to s and the partial of z with respect to t. So now you make your graph. You go z is here. It depends on r and it depends on theta. And then r depends on s and t, and theta depends on s and t. So when I want to find the partial derivative of z with respect to s, that is going to be the partial of z with respect to r. So I go here and I say, well, that's just 2e 2r sine of 3 theta times the partial of r with respect to s. Well, what is that? That's over here going to give us t, and then this minus t disappears. That's the first part. Plus, so now we have the partial of z with respect to theta. So going back here, that's just going to be e2r cosine of 3 theta times 3 times the partial of theta with respect to s. So that going here gives us 1 over 2 square root of s squared plus t squared times the derivative inside with respect to s, which is 2s. And this is our partial. Now, of course, if you wanted to just know this with respect to t and s, you would have to, every time you see an r in your formula, you will have to plug this in right here. And every time you see a theta, you would have to plug this in, for example, right there. But I'm not going to go over that. Any questions about this? So if there aren't any questions, let's start the quiz. Hey everyone, I'm going to share the screen with a quiz. Please be quiet. And there it is. Guys, please. Yeah. Well, I guess I can get rid of that part. This should obviously be problem 2. Okay. Oh, if someone is taking the quiz, I guess online, there aren't that many people, only one, so just email it to me. You have 10 more minutes. Please finish up. Have a nice weekend.
Sorry, how frequent are the Friday quiz is going to be?
Every Friday.
Every Friday? Is there going to be like a drop of like below?
I make sure.
Okay, cool. That's good.
Today, basically from now until 2. Sounds good. Okay, please finish up. You still didn't email me?
Oh, yeah. I have my email.
The quiz, well, there is, I believe, 100 points, which are alternative assignments, and it was gonna be homework, and I realized that. Sorry, what?
This will become
This will be 35 points
35 points.
yes, from the total. quiz. Yes.
Got it.